Hello there boys, welcome to today's video. Today we shall go through forces in motion assessment, the one you did. Now any question that you got wrong or any question that you got partly wrong, you need to pop pen your work fully. I need to see the working out to all those questions which you got wrong, pop a pen directly on your test. Okay, so now what I'll do is I will go through the questions, I will answer those questions, and also we are going to be looking at the mark scheme. Right, the first question. Now here we have question 1. A cyclist and a runner has a race. Okay, so two things are racing each other. The distance time graph for the race is shown below. So we know that we have distance, it tells us how far they're traveling and how long it takes. In this case, we have two cyclists and runner. Now let's take a look what we have at the start. So we know that they start the journey at the same point, as you can see here, and here they are diverging. So it means that the cyclist is outrunning the runner, and eventually they reach the destination. At this point here, as you can see, it's flat. So it means at this point, from this point onwards, the cyclist is not moving at all because it stays at 100 meters, and eventually the runner at this point here, at this point, that's when the runner meets the cyclist. All right. Now let's take a look at our question. Now, use the graph to answer the following question. How much time did it take for the cyclist to travel 100 meters? Now, we know that this here is the cyclist, the dark one. To reach 100 meters, so that's where it reaches 100 meters. So that's where it is pretty much, that's the point where it becomes flat. So here I would say it's around 8 seconds. So the answer here is going to be around 8 seconds. Now the mark scheme allow from 8 seconds, so any answer between 8 seconds, to 8.2 seconds. That's what the answer mark scheme allow. Because if you look carefully, so at this point it could be here, it could be here as well. Because this is the point. This is the point. So the dash and the cross, that's the point where it is becoming flat, and this is where it has reached 100 meters. Now I'll use a different color pen, which is a red pen, to show you. So if any one of you put here, that's wrong. If any one of you put these X's, this is wrong. Okay, so we are looking for the point at which the line meets 100. So this is the line that we meet 100. Okay, so these are the answers. Now, when the cyclist finished the race, how far behind was the runner? Now, just delete everything of this. We don't need. Now, that's when. So at this point, that's when the cyclist finished the race. However, the runner is here at point X. So at point X, the runner is here. So as you can see, the runner is way behind him. Okay, the runner is way behind him. Now, the question is, how far behind is he? Okay, so we know that this here is 100. Now, how far is this in this case? So now we drop down to this point, and we see that this point here is roughly 65. So we need to work out this change. So therefore it's going to be 100 take away 65, and this here would be your answer. Okay, and the answer would be 35 meters. Okay, now the mark scheme allows any answer between 34 to 36 meters, because this is the only possible answers, because I'm getting 65 here, not 60, not 60, not 70. Okay, I may have been lenient to give you the mark, some of your marks, but this is the correct answer here. So we need to be able to look carefully where it meets. Right, now how much more time did the runner take compared to the cyclist to complete the race? Now, so this is done. We can erase this. I can erase this. Let's take a look. So the cyclist finishes at 8 seconds. However, later on at this point, which is 12, this is the point at which the runner hit 100 meters. This is 100 meters. The entire line is 100 meters. At this point here, this is where at which it reaches 100 meters. So therefore, so from 8 seconds all the way to 12, that's 1, that's 1, 2, 3, 4, that's 4 seconds. So the runner was 4 seconds behind. Okay, now the Moss scheme allowed an answer between 3.7 to 4.3 if you misread some of those points here. However, this is the range, 4 seconds, as you can see here, because the cyclist reaches it at 8 seconds, and then 4 seconds later, which is 12, that's when the runner reaches 100 meters. Good. Now let's keep going. Now the cyclist is traveling at constant speed, meaning the speed stays the same. Okay, between 3 and 6 seconds. How does the graph shows this? Now let's take a look. Between 3 and 6 seconds. Now between 3, I'll use a different color pen here. Let me use purple. Now between 3, which is here, and 6 seconds, which is here. Now the line, it is a straight line. Okay, it is a straight line. And whenever we have a straight line, a straight diagonal line, we know that it is a constant speed. Now, how can we tell from the graph? How can you tell from the graph that it is traveling at constant speed? It is simple. It is simple. And if you remember, what we are doing a distance time graph. So therefore, the gradient, if we do the rise, the gradient will give us, so the rise over run will give us distance over time, which is speed. Okay, and there are a few possible answers now. So first of all, the obvious one I'll say is the line is straight. So whenever we have a straight line, a diagonal straight line, it means it is constant speed for this particular one. Or we can also say that the gradient is constant, because the gradient is not changing, it is a straight line. So these are the only possible answers there. So if any one of you say that the line is somehow straight, okay, then it is acceptable. Gradient is constant is acceptable. Okay, now let me show you the Moss scheme for that one. So here we go. Now the Moss scheme, as you can see, is here. Okay, so this here is a Moss scheme. So gradient is constant, it is a straight line. Do not accept line is flat, accept steady increase. Okay. Alright, now let's move on. When the race started, a different person, set off in this case at 2 meters per second. So it means every second he's traveling 2 meters. If it goes 1 second down, it means it's going to be travel 2 meters up. Okay, draw a line for the walker has covered 15 seconds. Now the walker, use a ruler. Now I will stress this, you need to use a ruler. If your line is not straight, you will not be getting your mark. Okay, now what I will do is I will delete these annotation because we'll make it messy. Otherwise it's going to be messy. I'm going to delete this. Okay, so we know that the person would start. Let me use a different color pen for this. Let me use orange. So start from 0. Okay, and then 15 seconds. Now let's take a look. So we know the speed is 2 meters per second. Okay, I want to know how far he's traveled in 15 seconds. So time is 15. So therefore, distance is speed multiplied by time. So that's 2 times 15. That's 30 meters. So in 15 seconds, you're going to travel 15 meters. That's where I know that's where it's going to stop. All right. Now let's take a look. What other pieces of information do we have? Here we go. Steady speed. So constant speed means the line will be straight. Straight line. I mean a straight line. Very good. So we did this in the first few lessons. So we need to have a straight line from here all the way to there. Now I am doing it in dotted line because I cannot use a ruler on the computer, but for you, it need to be straight as possible. Okay, If your line is not straight, then you'll be losing your mark. So start from 0, go all the way to 15 seconds and 30 meters there. This is what will give you 1 mark with your ruler. Now, how much time will it take for it to walk 100 meters? So you guys know the time. So time is equal to speed divided by distance. Okay. I did this wrong. Sorry, it's the other way around. Distance divided by speed, which is 100. Now the speed is 2 because traveling at 2 meters per second. So this will give us a answer of 550 seconds, and this will get us our answer because we need to calculate. Okay, good. Let's move on. Ooh, now we have a bus. Okay, a distance time graph is going on. Now let's take a look before we answer any question. Let's take what's going on in this journey. So it starts with 0. Okay, from A to B, and it takes about 40 seconds to reach B. Now from B to C, it is flat. So if it's flat, it means it is not moving. So not moving. Now A to B, it is straight, so it means it is going at constant speed. Okay, same thing here, constant speed. So here is going at a lower constant speed because the line it is less steep compared to the others. Alright, now let's look at the questions. The bus traveled the slowest between D and E. How can you tell this from the graph? And pretty much I already give you the answers there. Okay, because the gradient is less steep. Okay, or you can say the gradient is the shallowest. Okay, or you can say smallest distance in larger time. So as you can see, from D all the way to E, he has taken this many time and only travels this many distances. Okay, or you can say he has traveled a short distance. So from here to here, a short distance is a long amount of time. Okay, and I'll show you the answers on the Moss scheme with you as well here. Here we go. So here are the answers for question 2A. Shallowest slope or gradient, accept smallest distance in biggest time, accept longest time travel the same distance, lines not steep, less steep. Okay, however, do not accept the lines not steep. Okay, because the line has some steepness to it, which is not as steep. Right. Which of these 2 points was the bus traveling the fastest? Okay, now the fastest means speed has to be higher. Now, this here is lower constant speed because the line it is less steep. Now, this one here is steeper than D to E. However, if you look at this one here, if you look at A to B, the line it is steepest. It is steepest compared to the other one. Therefore, fastest. Okay, so the gradient needs to be steeper. Okay, that's how we can tell in this case. Okay, let's keep going. Alright, now this one here, this question here, most of you got this one right, except for one of the questions. Now, what is the distance between A on the graph and the bus stopped? Okay, so you guys already know this one here, this is 200. Okay, now how long is stop for? So with here, and you need to show your working out. Show your working out. So this bus stopped. We all know it stopped for 20 seconds. However, you need to show me that you are doing 60, take away 40 to get 20. So this here is 1 mark, and this here is the second mark. Okay, if you miss your working out, then you lost that mark there, because here it says clearly how, show clearly how you got that. Alright, now we need to draw a line again. The cyclist started on the same time, so we know same time, and completed it, we know the time it completed it. Now for the whole distance at constant speed, so it's going to be a straight line. And draw this on the graph. Now let's take a look what we have. So I will use a different color pen. Let me take a look green. Start 0. Okay, we can't see that. Let me use blue. So 0 and 200 seconds is there. And what does it say? It says it traveled the whole distance. So it means it's gonna go from, so this point is gonna reach the entire distance. Let me go up all the way here. That's the entire distance. That's where it will end. So therefore I'm gonna have a nice straight line. Here we go. Here we go. Here we go. Okay, here we go. Nice straight line. This is the blue one, is your straight line. Let me just delete these ones here. We don't need these ones. You don't need a dotted one anymore. Okay, here we go. Oops, I've deleted the other one for no reason. Okay, so it's going to be a straight line. Sorry, that's bad. Straight line, should be straight line. Make sure that you guys use your ruler. Okay, that's 2 marks. Now, how many seconds did it overtake the bus? Let's take a look. It is overtaking the bus. Alright, so I'll use a different color pen for that. This one. Now, at this point, that's when it's overtaking the bus. So we need to work out the time at this point. Now, I'll go down. So to go down, go down, go down, go down, go down, it's roughly here. So I'll say 150. Okay, 150 seconds. Let me just be more precise in this case. Okay, now you should be able to do this in a straight line. Okay, so if you think the graph in a straight line, alright, I'll try to do this as straight as I can. So I'm getting 160. So if you do it straight, then you should be getting a proper answer. So 160. Now some of you, I may have given you marks there if you do not get 160, because I've taken a look at your diagram. I've checked whether you've indeed completed the journey properly, and then do that. Otherwise, you may have not given the marks. Okay, so I've already checked this for you guys. If you did not get the mark, then you did not get the mark because you missed something there. Either you didn't align the line properly, or you didn't use a straight line. Otherwise, you have gotten the mark. Now, question 3. Now, we have 2 forces acting on the object. Now, what's happening to the motorcycle? It is moving. Okay, the motorcycle is moving, even though there's force A and force B on it. Now, describe the movement when the forces are equal. Right. Now, in this one, we need to understand what is going on. The movement of the car, the movement of the motorcycle. So we know that the forces are equal. Okay. However, it's moving, so it will not stop. Okay, so it means it's moving, will not stop. Now, how will it move? So far, what we have been doing, you see there's 2 words that's constantly being popping around. Okay, if I go in the front or the back, if I go from the start of the question, there's this word here, constant speed. Okay, here again, steady speed. Okay, and so on. So therefore, when the forces are equal, it means that the motorbike will travel at constant speed. However, you need to say where would it go. Okay, so you're going to carry constant speed forward. So because the motorbike is going this way, so even though the forces are balanced, it means it will travel at constant speed and it will go forward. Right, now let's take a look at what the mass schemes say in this case. Now the mass scheme says constant speed, okay, in a straight line. If you put the word constant velocity, you get 2 marks. If you say not accelerating, you get 2 marks. Okay. If you say terminal velocity, then you only get 1 mark. Now, for all those of you who said terminal velocity, you've only awarded 1 mark. All right. Let's move on. Now, what will happen if the force B is smaller? Now, let's take a look. Let me draw this again. So we've got our motorbike. Okay. Now, A is here. Now, B is smaller. What will happen? What will happen in this case? So let's say, how can B be smaller? Let's say the person applied brakes. So when I apply the brakes, B gets smaller. Now, what will happen to the motorbike? Now, the motorbike, it gets slower. That's it. It gets slower. And then eventually it will stop down. It will stop. However, before it stops, it gets slows down, or it decelerates. Decelerate. Okay. This is the possible answers there. All right. That's it. Okay. Good. And we are nearly done. Now we have another graph here as well. Now what we have is we have velocity and time, which is different. Let's take what we have. It's a straight line, it goes up, it goes down. So this here tells us how fast it is going. Okay, so from 0 to 6 seconds, so 6 seconds, it went all the way to this value here. Okay, so that's how fast it's going. Now question 1, what is the change in speed in the first 5 seconds? Now let's take a look. 0, 1, 2, 3, 4, 5. 5 seconds, then we go up. Here, so 20. So pretty much in 5 seconds, it goes from 0 all the way to 20 seconds. Right? Now let's take a look what we have. Okay, so the change is going to be 20 meters per second. Okay, that's the only possible answer that we have. Okay, another way you can do it is you can work out the gradient. So change in y. So change in y is going to be 20 take away 0, and change in x is going to be 5, so that's 20 divided by 5. Sorry, wait, I did this wrong. Sorry, I did this wrong. So we do not need to work out the gradient. We're just looking for the change in speed. So we just want to know in the first 5 seconds how fast it's going. So where it started with 0 goes all the way to 20 in 5 seconds. Okay, there's no need to work out the gradient. No. So if I write gradient here, put a cross there. Okay, if I've written gradient in your book, then put a cross there. That's wrong. Gradient, cross. Now work out the equation that links these two. So we need an equation that has acceleration, change in velocity, and time. So acceleration is equal to v minus u divided by time. Or if you write it in words, acceleration is equal to change in velocity divided by time. Or for those of you who have written down initial velocity minus final velocity over time, that is also perfect. Okay, now we need to work out acceleration. So we need to work out the gradient now. Gradient is equal to acceleration is equal to u is equal to v over t. So therefore 5 seconds is going to be 20 t equals 0 divided by 5. 4. Now we need the unit. Give the unit. Let's take a look. So we are doing velocity. So we are doing velocity divided by time. So now unit is going to be velocity. What's the unit for velocity? Let's take a look up. Unit for velocity is meters per second. So going to be meters per second divided by time. What's the unit for time? Let's go back and check. Unit for time is seconds, so seconds. So therefore, it's going to be meters per second squared. So therefore, it's going to be 4 meters per second squared. So you get mark for the answer and mark for the units. Good. Right, we are nearly there. Now, a car decelerates to rest with a uniform rate. So uniform means constant, okay, of 2 meters per second squared. So we know the acceleration. Work out the velocity in this case, the speed or velocity. Now, equation is here. What do we need to work out? The speed in this case. So here, it is traveling and it comes to rest. So rest means the velocity goes to 0. So that because stopping. So here, we're going to have 0, take away the speed, which we don't know, divided by time, equal to A. So A is 2. So 0 minus U is going to be minus U divided by time, which is 15. Okay. Now we need to work out the U. So we have minus U is equal to, when you do this way, it's going to be 2 times 15 equal to minus U. So 30 equal to minus U. Now the minus doesn't matter because the minus tell us about the velocity, if you remember. It's going to be 30 meters per second. So therefore the answer would be C. Okay. So you just need to know that the initial velocity, the initial velocity is what we're looking for. Okay, because it's speed before, and the final velocity it is 0 because it's stopped. Now, question 5. The speed time graph best represents the motion of being dropped from the surface to a deep lake. So let's say we have a lake, for example. Okay. So we got the rock, we drop it down. So we start from rest. Okay, so it means that the velocity, the speed, would be 0 at the start. So which of these graphs has speed 0? So this one is not 0. So look at this. 0 is here. So it is not this one. So either C, D, or B. Now let's keep going. Okay, dropped at the rest. Now what will happen? What will happen? Remember the graph for terminal velocity when we drop stuff. When we drop stuff, what will happen? It will go faster, and then it will start to slow down and then reach terminal velocity. Now, which of these graphs is showing that? It's not this one. It's not this one. It is B. If you remember terminal velocity graph, terminal velocity graph, because you are dropping it, and here the water is acting like air. It's going to speed up when it go, and then it's going to slow down because of resistance. In this case, will be water resistance. We're going to have water resistance against it, so water resistance, and eventually it's going to reach terminal velocity in the water, that is B. Now, the last question. An object has no unbalanced forces. So unbalanced forces, when the forces are unbalanced. So you have one which is bigger, one smaller. Now here saying it has no unbalanced forces. So if it has no unbalanced forces, it means that the forces are balanced. It means the forces are the same. Okay, so therefore the forces are the same. Now which one is not possible? Which one is not possible? Okay, if the forces are balanced, the object will stay at rest. Now let's take a look. If I have a cup of coffee on the desk, the forces are balanced, as you can see. The force is balanced. Okay, so this is true. So it stays at rest. It moves sideways with steady speed. Now let's say, so this one here is similar to the motorbike. When the forces are the same or balanced, what happens to the motorbike? It keep on going. So this is correct. This is correct. Okay. Now it moves up to 10 meters per second. Okay, it moves up at 10 meters per second. Now, so it means here I can take something. Let me take a ball. I raise the ball up 10 meters per second constantly. So this is correct. Okay. Which one's not true? Moves at a uniform acceleration, and this is not true. this is the one that's not true, because when forces are balanced, we know that speed is equal to constant. Now acceleration, if you remember, is the change in speed or velocity over time. Now if speed is the same, okay, then there's no change in speed. So for example, if let's say final velocity take away initial velocity divided by time. Let's say the final velocity is 1. Take away initial velocity. Let's say the initial velocity is also 1. So there's no change. So what happened? It's 0. So therefore, uniform velocity. So here, the word uniform acceleration means there is acceleration. Therefore, this is not possible. See? Okay, make sure that you properly pop up on your work. If you need to go back, if you need to stop and pause, do that. Alright, hopefully this helped you out. Once you've done, you can move on to your feedback question.